Okay, so the topic that we're covering today is distributed loads, and in the textbook it's section 4.10. But in order to get into distributed loads, you first need to understand some simple centroid, center of gravity, and center of mass. And I know you covered this in math and physics already, so I'm just going to remind you. But we're going to talk about just three simple shapes. So we have a rectangle, we have a square, hopefully it looks like a square to you, and a triangle. And what we need to do is be able to find the center of mass, center of gravity, and centroid. So let's define these three. So a centroid, do you remember what the difference between a centroid and center of mass and center of gravity are? They are a little bit different. Centroid is a function of the geometry of the item. So if we're talking about a two-dimensional body, the geometry that we're dealing with is area, because area is 2D. If we're dealing with a three-dimensional body, the geometry that we're dealing with is volume. So if we're looking at a 2D object, we have an X and we have a Y. This is two-dimensional. But if I'm dealing with a three-dimensional body, I'm dealing with an X, a Y, and a Z. So I would need to know where the centroid is of this 3D body and this 2D body. And as you could probably figure out, that if it's a two-dimensional body, I need 2 points, 2 coordinates to tell where the centroid of that body is. And for 3D, I'm going to need 3 coordinates to find the centroid of that body. Now, center of mass is not a function of the geometry, it's a function of the mass of the object. And the center of gravity is not a function of gravity, but what do you think it's a function of? How do we get from mass? If we look at gravity in terms of mass, we wind up getting to weight. So these are the 3 things that we need to be able to find the location of. Centroid, center of mass, and center of gravity. And in statics, we're always dealing with homogeneous items. Let's say homogeneous bodies is a better word. So we're really trying to find the physical center. So that means the center of mass, the center of gravity, and the centroid are at the same location. So let's go back to these 3 common shapes. So we have a rectangle, we have a square, and we have a triangle. Where is the centroid, or center of mass, or center of gravity of the rectangle? Let's say that this is X direction, and this is my Y direction. It should be halfway up and halfway over, right? So it's right here. So if I draw this line, this is going to be, let's say the whole distance right here is the base of the object. So this is going to be base over 2. And if this right here is the height of my object, the center is going to be here, which is h over 2. No problem. So that point there represents the centroid, the center of mass, and the center of gravity of that homogeneous rectangle. And I'm sure you would say the same thing with the square, right? If this is h, and this is b, the base, then the location of this is going to be b over 2 and h over 2. And in math and physics, you may have determined these locations based on integration. And when we get further along in statics, we are going to come back to this topic, and we're going to look at composite bodies, and we may have to use integration. But right now, for the topic of distributed loads, I just need to introduce these 3 simple objects, and the fact is you're going to know where the centroid is, and you don't have to do the integration. Okay, how about the triangle? Do you remember that one? Usually in statics, about half of you remember it. So here again is my height. Here again is my base. When we look at this, it's 1/3 up from the fat end. So this is where it is. It's 1/3 up. So this right here is h/3. And this right here is b/3. So we have to remember these. We're going to memorize these because we don't want to do integration to have to remember them. Okay? So this is what we need to do to even move into the topic of distributed loads.